So we're going to do exponential and logarithmic equations, and we're going to find the exact value of x along with the approximate value and just do 3 decimal places. Okay, so first problem is 3 to the 2x minus 1 equal to 11. What's different about these problems? Okay, there's no way I can rewrite these bases where they have the same base. So I need to use log properties, okay? So you can either just use a common log to run through this, or you can pick a log to get rid of the base. What's the base here for this here? Base is 3. So if I log 3 both sides, okay, so if I log 3 this side, that means I gotta log 3 the other side. Okay, and so those cancel, and so I get 2x minus 1 equals log base 3 of 11. So now I need to add 1. Remember, log base 3 of 11, this is just a number, people. So don't get too scared, just treat it like a regular number, okay? To get x by itself, I divide by 2. I divide everything by 2, okay? So my answer, my exact answer is log base 3 of 11 plus 1 all divided by 2. Okay, that's the exact answer. Now to get to 3 decimals, I need to use my calculator, but I gotta use the change of base formula for this piece right here. Okay, change of base formula, this would be log of 11 divided by log of 3. Okay, so let's go figure out what that is. Okay, log 11 divide log 3, all right? And then what was I gonna do? I think I add 1 to that, and I divide my answer by 2. So 1.591. So this is also 1.591, 3 decimals, okay? Let's try another problem. So I've got 3 to the 2x minus 1 equals 4 to the x plus 2. Now when I look at this, I've got exponents on both sides. So it really doesn't matter what our log base is because we're going to run into some troubles anyway. So what I'm going to do is I'm just going to use a natural log on both sides, okay? I like using the natural log. You can use a regular log. It doesn't matter. When you log it, you get rid of the exponential, okay? So ln both sides. When I ln both sides, what do I get? I get the natural log of 3, and then what happens to the exponent? It comes out front, right? So this whole thing is multiplied by what? 2x minus 1. And then this whole thing over here is multiplied by x plus 2. Okay? So remember, this is just a number. Okay, it's just a number. So I'm going to distribute that number into my parentheses. So I have 2 ln 3 times my x, that's just a number, minus ln 3 is equal to, and now I'm going to distribute this in here, ln 4, which is a number, times x, plus 2 ln 4. Okay? Now what am I trying to do? I'm trying to solve for x. So what do I need to do? I need to get my x's on one side. So minus ln 4 x for both sides, minus ln 4 x. And then I want to get my constants on the other side. So I'm going to add ln 3 to both sides. So let's collect like terms. So I got 2 ln 3 x minus ln 4 x equals what? 2 ln 4 plus ln 3. Okay, how do I get x by itself? I have an x here and an x here. I got to use that property everyone forgets about, the GCF. I'm going to factor an x out of each term. This is probably the hardest part, I think, for this problem for most students. So this is 2 ln 3 minus ln 4 multiplied through. I'm just going to copy and paste this because that did not change. And now how do I get this x by itself? I divide both sides. Okay, I divide both sides by this. And voila, my answer is x equals, and this is the exact answer right here. I know it looks complicated, and it is, but that's the exact answer. All right, now you could do some simplification if you wanted to, but I would take this as an answer. But if you wanted to simplify, you could simplify this. That would be ln 16, and then if you have ln of 16 plus ln of 3, that's the same as ln of 16 times 3, right? So this is what, ln 48 on top, and then in the denominator that would be like ln of 3 squared, which is 9, minus ln of 4, so that's like ln of 9 divided by 4 here. Okay, so that's a simplification. You don't have to do that, but it could help you out in getting the approximate answer. When you type this into your calculator, 3 decimals gets you 4.774. Okay, so that could be rather challenging to do, and it is pretty challenging for a lot of students. So what I'm going to do, I'm going to show you a way to do this to get to accuracy of 3 decimals without going through all this steps, okay? So maybe this will help you out if you're having a lot of trouble with this. So let's just take the same problem. 3 to the 2x minus 1 equals 4 to the x plus 2, okay? Now, let's just run with our log game, okay? So when I log it, I get log 3 to the 2x minus 1 equals log 4. Log 4 to the x plus 2, right? So same thing happens here. The 2x minus 1 comes out front, and I have the log 3. And then the x plus 2, and I have the log 4. But this is where it gets different, okay? Instead of using log 3 and log 4, I'm going to turn this into decimal form, okay? So I need to know what log 3 is. So that's 0.4771. So 0.4771, okay? And I need to know what log 4 is. Log 4 is looks like 6021. 0.6021, okay? Now, the reason I'm doing this is because a lot of students are more comfortable with decimals than they are with logs, okay? So if you're having trouble with this, you can use decimals, that's fine. So I need to know, what is 2 times 0.4771? So 2 times 0.4771, that gives me 9542. So 9542x minus 0.4771 equals 0.6021x. I'm distributing in here, and then I need to do 2 times 6021. 2 times 0.6021. I get 1.2042. Okay, so now what am I doing? I'm doing the exact same thing that I did up here. I need to get my x's to one side, right? So I'm going to do that. I've got x's on both sides. I want them on one side. So I'm going to subtract the 0.6021 from both sides. Okay, and I'm going to add just like I did up there. So hopefully this is a little more comfortable for you if the other one made you feel uneasy, right? So I need to do this. I can actually do that in my head. You can use a calculator if you want. Take the 1 down, the 2, the 5, and the 3. I think that's right. I hope that's right. 9542. So 0.9542 minus what? 0.6021. 3521. Yeah, that's what we got. And so this is equal to, yeah, that cancels there. This cancels here. So what's that add up to? This is going to add up to 3, and then 1, carry the 1, gets me 8, and then 6. So that thing right there. So I'm going to divide both sides by 3521. 3521. So 1.6813. 1.6813 divided by, what am I dividing by? 3521. 5.3521. Enter. And my answer, 4.775. 4.775. Now, why did this work for me? If I'm rounding to 3 decimal places, then what you have to do at a minimum, you have to write out 4 decimal places, okay, here. Otherwise, you might potentially have a rounding error and not get accurate to within 3 decimal places. So you still, like this one right here, like see how close we were? Yikes, right? So even with doing 4 decimal places, we didn't quite get it exactly accurate, but we were pretty dang close. Let me make sure that I didn't calculate that wrong. ln 48 over ln 9 over 4. So ln 48 divided, oh, that's what I wanted to hit, divided by ln 9 divided by 4. Okay, so yeah, this was a little bit off. So it wasn't accurate to 3 decimal places. So you might need to do 5 decimal places to make yourself, even closer to being to the correct answer. Okay, so you try this method, you're kind of taking a risk, right? You're definitely not going to get the exact value, and you might not even get to within 3 decimal places, but you're going to get close, right? So, maybe it's 5, maybe it's 4, maybe it's 6, but it's around that area there. So if you really want to make sure, maybe copy out to 5 decimals. I don't know. That's kind of had to be your call on that one. Okay, let's do another one. 5 times e to the negative x plus 2 equals 35. So the first thing I see here is look, this is a little different because I'm multiplying by 5 here. So the first thing I want to do is get rid of that 5 before I do any other algebra. I need to get the e by itself. Okay, so this gives me 7. How do I get rid of base e? I need to log base e everything. Now, if I log base e, that's the same thing as a natural log, right? I just wanted to write that out there just in case, you might have forgotten. It's been a while, right? A couple minutes. And so what happens to my exponent? Exponent comes out front. So that's negative x plus 2 times ln e equals ln 7. Well, guess what? ln e, if you type that in your calculator, those are inverses of each other. So ln of e, I don't like that. Let's just do second e button. That's just 1, as you can see there. Okay? So what do I get? I get negative x plus 2, and that's equal to 1. So that's negative x plus 2 equals ln 7. So what do I do if I minus 2 minus 2? I have negative x equals ln 7 minus 2. Divide by negative 1. I get x equals 2 minus ln 7. That's the exact. To get the approximate, type it in your calculator. 2 minus ln 7, and that gives me 0.054. So x is 0.054 approximately. Okay? Let's try another one. We're just rolling through these. Okay, log base 7, 3x minus 2 equal to 2. Okay, I see a log here. Now, how do I get rid of a log 7? Well, the base here is 7. So I raise both sides to a base 7, and that cancels it out. I get 3x minus 2 equals 7 squared. So that's 3x minus 2 equals 49. So I add 2. 51 equals 3x. Divide by 3. X is equal to what? 17. Okay. Exact answer is same as the approximation here. You don't need to put 17.000, but if you want to, I'm not going to count that wrong. Okay. So next one, ln x minus ln x minus 1. You know what? I think we'll save this one for another video because we're actually going to use some extra properties here. Okay, so we'll stop there for that video, and then we'll pick up for the next one.